In this question, a round ball of mass 0.4 kilogram is in equilibrium at the bottom of a V-shaped groove. It touches the sides of the groove at A and B, and the groove is not symmetric. The angles are given. We need to find a free body. We need to draw a free body diagram showing the correct directions of the normal force, normal forces, and the gravity force. So, if you want to draw it, that's gonna look like this. I'll just draw it first here and then I will make it fair. So one normal reaction in sub A is going to come at perpendicular direction from here. Uh, so this is at 90 degrees, and another one was coming as 90 degrees from here. So that's N sub B, and the weight is definitely going to act down. So this is how the weight is. Okay. This is 90 degrees, and this is the required, what do you call it as, the direction. So let's try to find out the angles now. So this is, I mean, this is N sub A, and this is N sub B, and this is the weight. So if I'm interested in the angles, so this is the normal reaction, right? And if we draw a horizontal line, then as per the alternate angle, this is also 45. And since this complete thing is 90, so this is also 45. So I can say that it is inclined at an angle of 45 degree to the horizontal. And likewise, the normal reaction at B is at 90 degrees. I draw a dotted line over here. So this is 75. So this will be 15, right? Because this will be 90 minus 75, which is nothing but 15 degrees. So I can say that with the horizontal, this angle is 15 degrees. This is the normal reaction at B. Okay. All right. So this is the FBD. Now in part B, we have to write the vector equation of the x and y component. So the x component of NA is going to be NA cosine of 45 degrees towards I cap. For NB, that's going to be NB cosine of 50 degrees towards minus I cap. And that should be equal to 0 because it is at rest. And for the vertical, this is for the x component. For the y component, that's going to be n sine of 45 degrees towards the j cap, then n sub a, then nb sine of 15 degree towards the j cap plus w towards minus j cap. This should be equal to 0. So that is in terms of NA, NB, and NC. Then in part C, they are talking about the magnitude and direction. So definitely we get rid of the I cap and J cap. So it will look like NA cosine of 45 degree should be equal to NB cosine of 15 degree, because the left side and the right side should be equal since they are at equilibrium. And likewise, this is for the X direction, and for the Y direction, likewise, that's going to be the vertical component as an NA sine of 45 degrees plus NB sine of 15 degrees. This should be equal to the weight, and weight is nothing but mg, right? M is zero point 0.4, so I just calculated separately. M is zero point 0.4 and G is 9.8. So this value comes out as 3.92. Let's call it equation 1, and let's call it equation number 2. All right. And in part D, we need to calculate the value of NA and NB from equation C. So that's pretty straightforward. From equation number 1, we are going to find the value of N sub A by dividing both sides by cos 45. In fact, cos 45. So that's cos 15 over cos 45. Let's call it equation number 3. And this N sub A, we are going to substitute in equation number 2. So from 2, N sub A is N sub B cos of 15 over cos of 45 degrees times sine of 45, because sine of 45 is over here anyway, plus N sub B sine of 15 degrees is equal to 3.92. Now remember, sine 45 and cos 45 value is same, right? So they can just cancel out like this. n sub b comes common, and we are left with cos 15 plus sine 15. That is equal to 3.92. So the value of n sub b comes out as cos 15 plus sine 15, and 3.92 over this value comes out as 3.2 Newton up to two decimal places. Uh, Actually, it's 3.2 Newton up to two decimal places, 3.20. And from this NB, we can easily find the value of NA from equation number 3, as NA is equal to NB, which is 3.2 times cos of 15 degree over cos of 45 degrees. So that's where the calculator comes in once again. So this value comes out as 4.37 Newton. That is the normal reaction because of A. Thank you.